What's going on, guys? So welcome back. In this video we are going to do two main things. First, we are going to set up RIP, and we are going to do redistribution between RIP and OSPF domain, and we will set up a virtual link to connect area 67 to area 0. As of now, the only routes that I'm missing, if you go over to R7, let's go over to R7 real quick. There we go. Set CLI Logical-system R7. Show OSPF neighbor. I do have an adjacent with R6, but if you look at the routing table, show route protocols, look at the OSPF routes that are present in R7. As you can see, I have learned only the loopback that's coming from R6 and the link between R3 and R6. These are the only routes that are present in area 67. In the same way, the routes that are in area 67, they are not making past the R3. And I'm not even sure if R3 has learned anything from area 67. Let's just go over quickly to R3 and show route protocol OSPF. Do I have anything from area 67? Yeah, well, nope, nothing. So because again, area 67 is not directly attached to area 0, so that's why. And here, same way, we haven't done anything on the RIP. So let's start off by set up RIP. So let's jump over to R5, and here I can say show configuration protocols. I do only have OSPF, so let's go in config, and I'm going to say edit protocols RIP. Show, I have nothing, so let's do set group. I'm going to call this RIP good name here. Let's just click on RIP. RIP neighbor. RIP neighbors. Call the neighbor. I'm going to specify neighbor is going to be the interface. So in this case, it's gig 005.58. Okay. And we need to specify the policy that will be exporting RIP routes, because the default export policy for RIP routes in Junos is reject. So you have to tell the system to advertise RIP routes. So I'm going to say set policy options, policy statement. I'm going to say export RIP school 10.1 protocol direct. Yeah. I'm going to export the connected route, and let me specify the interface, because the interface on the other side belongs to OSPF area 25, so I don't want that to be included. So let me just say 10.1 from interface G005.58, and the second term should be from protocol RIP, and I am going to then and accept, and term 1, of course, I should specify the terminating action and accept, just to show compare. Now we need to apply this policy to the RIP as an export policy. Set protocols RIP, the group that we specified, and I'm going to say export. If you hit question mark, you'll see the export policy there. Export RIP, say show type and compare, and commit, and quit. So I'm going to do the same on R8. Jump over to R8. So on R8, show configuration interfaces. I went ahead and add more subnets, as you can see here, so that we can have more external routes. So I'm going to do exactly the same what I have done in R5. I will pause the video and I'll come back when I complete that. So on R8, I went ahead and do the following. If I show type and compare, so this is what I have done. I have started a RIP process, call it RIP neighbors, and I specified my interface. I have loopback 0, unit 8, and of course the link between R8 and R5. And I have configured an export policy, call it export RIP. And here, because this router is completely in the RIP domain, I just exported all the routes that are coming from RIP protocol and all the my directly connected interface. And I have attached this policy as an export policy to my RIP process. So let's hit and quit. If I jump back to R5 and say show route protocol RIP, I should see I have learned all the prefixes from R8. Now let's do the redistribution. If I say show configuration policy options, type display set, you can see here this is the policy that export RIP routes into RIP domain. Anything that I receive from RIP protocol, I actually send it out to another RIP neighbors. So basically here, what I need, I can chip in the OSPF statement and say anything also that comes from protocol OSPF, the routes that are being received from OSPF protocol, I need to export them to the RIP domain. Let's say edit policy options, policy statement, export RIP. If I say show, I can say set term 2 from protocol OSPF, and that's it. Say top, show, and compare. If I say commit and quit, and let me jump over to R8 and see what do we have here now. Show route, and if I say show route protocol protocol RIP, you see I have all these routes that belongs to the OSPF domain, and they have been redistributed into RIP domain as RIP routes. That's cool. So if I jump back to R2 and say show route, I still don't have any external routes from the RIP domain. So here on R5, let's jump back to R5. I'm gonna need another policy. Say set protocols, set policy option, policy statement, say RIP to OSPF, specify from protocol RIP. Then accept. Basically what this says is anything that comes from RIP domain, just accept it, and I'm going to attach this policy as an export policy to the protocol OSPF. Export RIP to OSPF. Compare real quick. Commit and quit. Now let's jump back to R2 and say show route protocol OSPF, and sure enough I have 10.8. It has a route preference of 150, which is an external route, and the rest of the 172 that I added. If I jump back to R9 and say show route, I should have all the routes over this guy over here and another one here. What about R6? These routes made it to R6. Of course they should have it here, and 172.30.0.1 should be able to reach the loop back on R8 from R6. Now the redistribution is done, and let's now go and set up a virtual link so that Area 67 can learn all the routes that are coming from other parts of the OSPF domain. So the virtual link normally is normally being set on the ABR. So you are not going to set it from R7, but these two routers will be involved in the setup of the virtual link. So let's go to R6, and what we are going to do here is, let's say, edit protocols OSPF area 0, and I'll say enter. Show. So I have nothing here. I'm going to say set. If I hit question mark, you will see virtual link, because what I'm trying to do is kind of like attaching area 67 to area 0 through area 36. So it's going to set virtual link, and here we only have two options. So the neighbor ID is going to be the router ID of R3, which is 10.3.3.3, and I am transiting through area 36. Oops. And that's it. Let's go at the top, show pipe, and compare. Let's commit and quit, and we are going to do the same on R3. So I'll jump over to R3, say edit protocols OSPF area 0. I'm going to set virtual link. Neighbor ID is going to be 10.6.6.6, and I'm transiting through area 36. Boom. Going to the top, show pipe and compare. Okay. Commit and quit. Now, if I now say show OSPF neighbor, I should see another adjacent just came up. There you have it. It's a virtual link. If I say show route, I should be able to see the prefix from area 67. There you have it. And 10.7.7, where is it? Yeah, there you go. Let's jump back to R6. Let's say show OSPF neighbor. I should have that adjacent over virtual link. And if I go to R7 now and say show route, I should pretty much have all the routes for the entire domain. Let's ping 10.9.9.9. Now I should be able to reach so now we have populated routes to the entire topology. Let's go quickly over to R9, say show OSPF database. Let's just analyze this one quickly. Then, as you can see here on R9, which is area 19, how many LSA types do I have here? I only have type 1, which belongs to this area. I don't have type 2 LSA because this, in the previous video, we set this link as a point-to-point, and I have a bunch of summary LSAs, type 3 LSAs that are coming from other areas, and the advertising router is R1. And of course, I have a type 4 LSA, which tells me about the ASBR, the Autonomous System Border Router, which is R5, which is right here, which is redistributing these external routes from the read domain. So let's just end it here, and in the next video we will go over stub area and totally stub areas. Until then, I'll see you in the next video.